This is just going to be a quick and dirty illustration of how to compile Linux kernel module and insert it into the kernel, remove it from the kernel, and interact with it. Um, these files are available on the course website. So the first thing I'm going to do is to create the device file. So this kernel module is a device driver, and we interact with it through the file system through a device file. So the first thing I'm going to do is create the device file. That's a privileged command, so I'm going to use sudo. Okay, so the file will be named chardev. It's a character device as opposed to a block device. The device driver is being identified with a major number of 100. So we use the major number 100 to identify the class of this device. And then the minor number here is 0, indicating the instance of the device. Now I'm going to chmod it so that anyone has read and write privileges on the file. Now let's look at, okay, so here are the read-write permissions for everyone, the major number and the minor number. So there's the entire directory. Let's go ahead and build the module. Well, that compiled successfully. Let's insert it. Let's see, that's sbin/insmod rdev. Okay, so it's a kernel object. So this is a file, the module file to insert. Okay, so now I should be able to interact with the device file. I'll echo world into the device file. Now read it back. Now let's echo you can say okay, finally a test program that uses some of the I/O controls. So I'll run that. Okay, you can look at the source code for that C program. It does a number of things. It interacts with the device file using I/O controls, which allow us to extend the functionality of the device by doing some things that we wouldn't ordinarily do through files. So Linux is abstracting the device as a file, and that puts some limitations on us. The I/O controls allow us a mechanism around that, and then at the end of the program, you'll see that I'm interacting with the device through file system read and write operations. So that's the quick introduction to kernel module files. Let me just demonstrate how to remove. All right, so that removes, unloads the module. That would be necessary if your module successfully compiled and you inserted it, but then noticed that it wasn't behaving properly. So what you would do at that point would be to remove it, fix the problem, recompile the module, and then reload it. So remember, if you make revisions to kernel module, you have to reload the module into the kernel. The kernel doesn't automatically pick that up. So that completes our quick introduction here.